Okay, so I just did a video on naming ionic compounds. I'm also going to do a video on how to kind of understand these polyatomic ions because I think some people might be a little bit confused still. So when you're looking at the polyatomics, again, this chart is on page 220 in the textbook. I also posted notes on focus for polyatomic ions, and there's another chart inside of those notes. So either one you can look at. The notes are on focus, or if you're in class, page 220. All right, so for your polyatomics, the majority of your polyatomics are going to have negative charges. There is only two polyatomics that you guys are expected to at least recognize, which are positive. So ammonium, NH4 positive, and dimercury, which is also called mercurous, which is Hg2 positive. So in reality, dimercury is actually just mercury 1. So mercury is a transition metal, and mercury 1 would mean that it has a positive 1 charge. Well, in nature, mercury 1 doesn't actually like to exist all on its own. It will always find another mercury 1, and they will pair up to form Hg. There's two of them, 1, 2, so I have two atoms of mercury, and because each one of them has a positive 1 charge, when you add that together, it becomes Hg2 with a 2 positive charge. That is where dimercury comes from. It's really not a polyatomic. It's just like it says down here, the mercury 1 cation exists as Hg joined together. We're going to learn about covalent bonds later. All right, so coming down, we have acetate. Acetate is a funny one. So CH3, and then it's COO negative. You can sometimes see acetate written like this: carbon, hydrogen, carbon, oxygen, oxygen. You'll also see it in the way that I actually prefer it because it's easier to remember, is C2H3O2 negative. So they're the same. See, 2 carbons, 2 carbons, 3 hydrogens, 3 hydrogens, 2 oxygens, 2 oxygens. But most important, it has a negative 1 charge. Just to reiterate, if there's just a little line like that, it means it's negative 1. You don't have to write the 1, it's implied. So these both are acetate. Okay. And you can just keep going down the list. Here we have bromate, chlorate, chlorite, bunch of different polyatomics. What I really, really want you guys to remember, if it ends in ATE or ITE, you can definitely understand that this is going to be a polyatomic. We know that monoatomic ions, things like Br minus, this would end in IDE. This would be called bromide, IDE. But polyatomics, something like BrO3 negative, that would be bromate. So if it ends in ATE, it's definitely going to be a polyatomic. Something else, BrO2 negative. Well, it's still a polyatomic. This one is called bromite. So ITE is another way to recognize it's a polyatomic. So if it ends in ate or ite, polyatomic. If it ends in IDE, it's a monoatomic, meaning it's just one single atom. There's a few exceptions to that rule because, like everything, there's exceptions. So cyanide ends in IDE, and yet it's a polyatomic. It's carbon and nitrogen. Also, hydroxide ends in IDE, right there, but it's OH, polyatomic. Pretty sure that's about it, though. Yeah, that's about it. Those are the only two. So if you can just remember, cyanide and hydroxide are those exceptions. Even though they end in IDE, you'll still have to find them on this chart on page 220 or in your notes. Last thing I would want to talk about is the endings 8. Let me get a better paper. Let's do it over here. Excuse me. So the endings 8, ite, hypoite, and perate. So we kind of talked about this in class, but just to reiterate, 8 tends to be what we call the reference. Not all elements, or excuse me, not all polyatomics are going to have all 4 versions of these different ways to do the root. So you want to come over here. Let's pick one. Let's look at something that ends in 8. Perchlorate, that has the per, so I don't want that. I just want something that's just something H. Chlorate. Very good. So chlorate, we just saw, was ClO3 negative. The only way I knew that is because I went to the chart and I found chlorate. Well, right below it, you can see chlorite. Even if I didn't have this chart, as long as I know what chlorate is, I can figure out the rest of these. So chlorate has 3 oxygens. That's my reference. If it ends in ITE, so let's say instead of it being chlorate, let's say it was chlorite, ITE. It's going to have 1 less oxygen. So instead of ClO3, it's going to become ClO2 with a negative charge. Okay? Now, if it started with hypo, so let's say it was hypochlorite, it would actually have 2 less oxygens than the reference. So hypochlorite that's a thing, it exists. Instead of 3, it's going to have 2 less. So that becomes ClO1 negative. But of course, this one, I don't have to write it. It's implied. So just ClO and a negative charge. Notice, the charge does not change. They are all -1. What's changing is the number of oxygens. So the reference was 3. If it's in the ite form, it has 1 less. If it's in the hypoite form, now has 2 less. And the last one is per8. Per8 is going to have 1 more than the reference. So for instance, perchlorate. That's going to be ClO4. So there's the reference 3. That's the 8 form. Perchlorate is going to have 1 more, ClO4. But of course, the charge is not going to change. It's going to remain -1. Okay, so even if you can just remember chlorate, you can figure out the rest of these just by remembering ite is always 1 less than the 8, hypoite is 2 less, and per8 is 1 more. Something else that's really interesting, as long as the elements are in the same family, for instance, chlorine, bromine, iodine, these are all halogens. They're all in group 7. They're going to follow the same pattern. So if chlorate was ClO3, bromate is going to be the same thing. Bro3 negative. Same charge because they're in the same family. This would be bromate. Well, what do you think bromite is going to be? Just like chlorate, over here, chlorate has a 3. Chlorite is now ClO2. Bromite is the same thing. Bro2 negative. What is hypobromite? Well, just like hypochlorite, it's going to be Bro, just 1 single, and of course that negative charge. And what about perbromate? Well, just like perchlorate up here, it's going to have 4 oxygens and a -1 charge. I could have said the same thing for iodate. So iodate refers to iodine. Even if you didn't know it, just because you know chlorate, you now know iodate. I can imagine you guys have already come up with it, I hope. IO3 negative. See, chlorate is ClO3 negative, iodate IO3 negative. What do you think iodite is? IO2 negative. Hypoiodite, IO negative. And iodate, excuse me. You should always have per with 8 and hypo should always go with ite. That should be IO4 negative. So again, they're all in the same family, chlorine, bromine, and iodine. Chlorine, bromine, and iodine. Therefore, they follow the same pattern.